Okay, good evening, ladies and gentlemen. This is Professor David J. Delos Okay, the date for today is December 8, 2023. In the time, it's 11:37 p.m. Okay, my topic for this session will be a continuation of my subject matter trigonometry. It's a long video format. So for those of you who are planning to take up engineering or want to be more versatile on the so-called study of trigonometry, this is for you guys. This is the base foundation that I could give you if you want to learn trigonometry. Okay, let's proceed. The subject matter for tonight will be trigonometry, and this is now lesson number 40. Wow, we are running smooth. Okay, I think we are almost 80% done with the study of trigonometry. So this will be a good preparation if you plan on taking up engineering. Okay, the title of the topic for tonight will be Problem of Cotangent Addition Formula. The last time around, I derived the formula the formula on the so-called expansion of the cotangent of the sum of two angles. So for tonight, I will try to give you an example problem for us to visualize the so-called validity or importance of this one. Was the derived equation or identity correct or not? Of course, it should be correct, but for tonight, okay, we will check the validity by giving us or not giving us, by bringing out an example problem for us to check the validity. Okay, let's proceed. Example, this should be example, right? Find the cotangent of 75 degrees. It's just a simple problem, but it involves a concept on how to solve it. Find the cotangent of 75 degrees. So by knowing the expansion of the cotangent of the sum of two angles, okay, if we try to bring out the solution, cotangent of 75, okay, addition formula under cotangent, so we could bring out a sum of two angles in which if we try to take the sum, it should be 75 degrees. I think the logical number of degrees to bring out is actually the combination 45 and 30. It could be 60 or 15. Okay. 60, we could bring out the values even without using a calculator. But for 15 degrees, okay, I think 15 degrees is not a special angle. So actually, if we try to bring out the values of the 15 degrees, we must have to use the calculator. So I prepare the combination 45 and 30. Because 45 degrees is a special angle, 30 degrees is a special angle. So if I would like to bring out the value of the triangle functions for 45 and 30, there will be no problem. Okay, let's try to bring out the solution. Cotangent of 75 will be cotangent of the sum of 45 plus 30. This was the derived equation the last time around. This is actually angle A. This angle A. That's angle A. That's angle B. Okay? Meaning to say, if we try to expand this one, it should be the cotangent of the first angle, okay, times the cotangent of the second angle, which is B will be equal to 30 degrees, and A will be 45, minus 1, all over. The sum of the cotangent of the bottom portion should be cotangent of 45 plus cotangent of 30 degrees. If you forgot to recall this formula, you've got a problem because actually the essence of the, what you call this example tonight is the application of this formula. So without having to recall this one, if you could not recall it, you've got a problem. Okay? So this is the proper recalling. This is cotangent of A, cotangent of B minus 1 over cotangent of A plus cotangent of 30. And which the value of A is 45, the value of B is 30 degrees. And for the values, we do not have to use our calculator because like what I said, 45 and 30 are actually special angles. Okay, let's try to go back to the 45 and 30 degrees before we will substitute the value. For a 45 degree triangle, the logical thing to think, if it is 45 degrees, tangent of 45, okay, tangent of 45 is actually 1. Is actually 1. So if this is 45 and tangent, the marking of a 45 degree, for us to remember it is that tangent of 45 degrees is equal to 1. So the opposite side will be 1, the adjacent side will be 1. The hypotenuse will be the square root of 2. Pythagorean principle. The square of 1 plus the square of 1, that will be 1 plus 1, which is the square root of 2. So just in case we needed the trigo functions for 45, there will be no problem. We are all given the sides already, and if we try to recall the definition of the different functions, we could bring out the values, right? So in here, actually we needed the value of cotangent, and cotangent of 45 degrees. Cotangent is the reciprocal of tangent. If tangent is opposite over adjacent, okay, cotangent is adjacent over opposite. So it will be 1 over 1, and 1 over 1 is 1. So we now know the value of cotangent here. Cotangent of 45 degrees is equal to 1. Right? That's why, like what I said a while ago, I do not need the calculator with this combination 45 and 30. For the 30 degrees, if we try to draw the 30 degree triangle, the logical, what you call this, marking of the 30 degree triangle is that the sine of 30 degrees is actually 1/2. So if this 30 degrees, sine is actually opposite over hypotenuse. So meaning to say, if the logical sine of a 30 degrees is sine of 30 degrees is equal to 1/2. This is just the value we need to memorize to bring out the different value of a 30 degree angle, even the 45 degrees. Just memorize this, you could bring out this one. Just memorize this, you could bring out this one. So if this is 1 and this is 2, the adjacent side should be the square root of 2 minus the square root of 1, and this should be square root of 3. So if we try to bring out the cotangent of 30 degrees, again, cotangent is actually adjacent over opposite. So it should be square root of 3 over 1. This is square root of 3, over 1, or just simply square root of 3. See, you see, guys? I brought out the value of cotangent of 45 and cotangent of 30 degrees without using a calculator, by just knowing, okay, that tangent of 45 degrees is 1 and sine of 30 degrees is 1. Okay, this is in my mind already. So I hope you could do that also. So by knowing the value of cotangent of 45 and cotangent of 30, it's just a mere substitution now. So cotangent of 45 is 1. Cotangent of 30 degrees is square root of 3. This is minus 1. We are following this. All over 1 plus the cotangent of 30 is actually square root of 3. 1 times the square root of 3 is square root of 3, and square root of 3, okay, even square root of 3, for engineers who have been engineer for a long time, we actually memorize the square root of 3. It's 1.732 minus 1 all over 1. Again, the square root of 3, 1.732. Just perform the algebraic simplification. That's algebra, right? So it will be 1.732 minus 1 will be 0.732. 1.732 plus 1 will be 2.732. And if you try to divide this one by using a calculator, the approximate value of cotangent of 75 degrees up to 4 decimal places is 0.2679. Okay. So we were able to brought out the cotangent of 75 degrees by using the expansion of the cotangent addition formula and by using our knowledge of the so-called values of special angles without using any calculator. I am not telling you that you could not use the calculator, but for me, I just presented this solution without using the calculator by just taking the combination 45 and 30 degrees. Okay, let's try to check the validity of the answer. To check the validity of the answer, if it is correct or not, check using the calculator. Okay, this is just for checking purposes. Okay, so don't be a slave of the calculator. At least we know what the calculator could do, and actually we could do it. So we'll just place 75 degrees here. But if you try to use the calculator, you could not bring out the cotangent without knowing the tangent, because in the calculator, what is only on the calculator is sine, cosine, and tangent. The reciprocal functions are not here, meaning the cosecant, the secant, and cotangent, it's not here. So to bring the cotangent value, you just take reciprocals. So cotangent of 75 degrees, cotangent and tangent are actually reciprocals, right? So this is 1 over tangent of 75 degrees. So this is 1 over tangent of 75 degrees, 3.732 up to 3 decimal places. So if we try to divide 1 over 3.732, 1 over x, the answer up to 4 decimal places is 0.2679. So this is 0.2679. It's true. Okay, that's it, guys. This will be an illustrative example on the concept, on the so-called addition of a cotangent addition formula. Okay, good evening from Los Angeles. This is Professor David J. DelosReyes. I hope you understood what I explained. Good evening.